Good afternoon, guys. How are we doing today?
Hanging in there.
Good, good. Me too. That's about all I can say. Although I ended up getting sick over the weekend, so my throat and my head are killing me right now. Just surviving. I hear you, Tim. I hear you. Okay, guys. We're gonna not delay because we've got a lot of stuff to get through today. So I'm just gonna keep letting everybody in as they come in. And our goal today is to go through, just do quick announcements here in just a second. And then we're going to go through and make sure you guys have a good handle on what analyses need to be ran if you haven't ran them already. Some of you have. And then we're going to talk through how to create a table and a figure. Okay, so or a table and a graph. And graphs are called figures in peer-reviewed publication. And we'll talk about some of the important aspects that where tables and figures can actually stand alone. And then just a second, I'm sorry, I have to take a way away from a puppy. Just a second. Sorry about that. She found a plastic water bottle, was attempting to kill it. So, and then after we get done going through tables and graphs, we will then focus on outlining the discussion. Okay, so we've got a lot of ground to cover today. One really quick announcement, or two of them actually. The first is that part 3 is due on Friday. Okay, so I don't think that's any mystery to anybody. So we've been working on it for the last 3 weeks. And we're also going to do 2 writing workshops this week. And my schedule is a little bit crazy, so I couldn't do them until the end of the week. I apologize. But the first one will be on Thursday, November 18th from 10 to 11 a.m. And the second one will be on Friday, November 19th from 8 to 9 a.m. And if those don't work for you, I still have some booking appointments available for Thursday and later on Friday as well. So feel free to grab one of those if you can't make one of the writing workshops. All right. I'm going to go ahead and share my screen with you, and we're going to jump to a PowerPoint slide set. So I thought that this might be a little bit easier for us to go through. And then I am also, I've got my tablet up too. So I'm going to try to do some interactive stuff with drawing on slides and that type of thing. So we'll see how well this actually works. There we go. Okay. All right, so just a couple of quick announcements about part 3, some general tips to help you guys. It is totally fine for you to add the results and discussion sections to what you've already created and turned in for part 2. Even though you don't have edits back for part 2, that is okay. I'm going to get those to you over the break. But you guys are more than welcome to just keep creating a big, long document. Okay, so I can scroll through introduction and materials and methods and just read the results and discussion portion. So I would rather us keep building the final document than you guys have to keep track of multiple files. All right, so please don't forget that to check the original assignment and the appropriate rubric for part 3. Those are in or on Blackboard. Also, please make sure to keep writing in past tense and third person. Okay, so research is always done in the past tense, and so we are transitioning there this week. So right now it's very much present tense, but we're going to write like it's past tense. Okay, and then third person. So again, no I's, no we's, no me's. We want to keep first and second person completely out of scientific writing. Feel free to refer to the good examples papers on Blackboard. They're there for your reference. Okay, and then the results section should absolutely contain either a table or a figure. Okay, that's a big part of the points in the rubric. Okay, so keep in mind that where the table and the figures actually appear is after the first paragraph in which they're mentioned. So we want to make sure that we're not splitting a paragraph, and we want to make sure that we're not starting the section with a table or a figure. Okay, so it's proper scientific writing is you have some verbiage in a paragraph form, and even if you mention the results of this are in figure 2, then you go ahead and write the rest of the paragraph, and after the end of that paragraph is when you actually build in figure 2 or table 2, whatever your first table or figure will be. All right, so those are just some general tips. I may add some more to that eventually. Last week, we talked through the different analyses that need to be conducted. And so I wanted to condense that a little bit just to make sure that you guys were actually able to run all the analyses that you need to. So I'm hoping that this makes it a little bit more clear. So we're going to assess both temperature and moisture on day 1, 18, and 38. So for temperature, day 1, you need to run an ANOVA analysis. Temperature day 18, you need to run an ANOVA, and temperature day 38, you need to run an ANOVA, so 3 separate ANOVA analyses for temperature, and then 3 separate moisture ANOVA, or 3 separate ANOVA analyses for moisture as well. And then pile height, we only have data for either the bone in or the boneless data. We don't have day pile height. And so all you need is to run 1 ANOVA analysis for pile height. All right. The nutrient data is a part of the master data sheet that is on Blackboard. And there are 5 different nutrient components that we're going to look at. So you need to run an ANOVA analysis between bone-in and boneless results for total nitrogen, total phosphorus, potassium, organic matter, and moisture. And then the last analysis actually refers to the 3rd objective of our study, where we actually assessed the relationship between temperature and pile height. And we did that within a regression analysis. And if you turned in the assignment from last week, you actually have already done that. So the regression analysis results you can pull out of what you submitted last week. All right, so any questions about the analyses that we're running? So really quickly, guys, give me a thumbs up if you are completely done with your analysis. You maybe haven't started writing stuff up yet, but you've ran all the ANOVAs and the regression analysis. Give me a thumbs up. A couple, great. Okay, cool. How many of you guys have started the analysis, but either with today's explanation or just a lack of time, you haven't gotten completely through them? Okay, sounds good. Thank you. All right. Truth tellers, it's truth time. How many of you guys have not started the analysis at all outside of the regression that we did turn in last week? Okay, I love honesty. So I'm going to challenge those of you guys with thumbs up right now. You need to hammer down, okay? Because you have a lot of work ahead of you before Friday. Okay, so let's go back and keep trucking with talking about tables and figures. All right, so in the rubric for part 3, you actually have a line item there where you present at least one set of results using either a table or a figure. Okay, so results can be presented one of 3 different ways. But we have to keep our reader in mind. Okay, so people tend to better understand graphs more so than tables. Tables more so than text. Okay, so the 3 ways that data can be presented is in a graph, in a table, or actually in written paragraph form. All right, so we're going to do a combination of things. Okay, so you can present your data in all graphs if you want. I'm fine with that. You can present your data in all tables if you want. I'm fine with that, with the exception of the regression analysis. Sorry, gosh, dang it. Or you can actually present a part of your data with in paragraph form. So either way, paragraphs are going to accompany a table or a figure. All right, so for those of you guys that are considering making a table, I'm going to just really quickly run through how to do that, but in Word. Okay, so let me get out of here. Let me stop sharing. Let's pull up a Word document. Okay, we'll go back and just share the screen. Okay, so since you guys are already writing in Word, I'm going to encourage you to use the Word table function. It will make your life easier. It's actually pretty versatile. Okay, so if we wanted to start a table, I'm just going to space down one really quickly, and then I'm going to go to Insert, Table, and we'll just pick one here or a size here just to get us started. We can always add columns and rows later on. Okay, the first thing I'm going to do is I'm going to adjust my lines. Okay, so in scientific table creation, the only lines that are used are horizontal lines, and that is to separate the headings from the data that's presented. And then we use one border at the bottom to indicate the end of a table. So what I'm going to do first is go to, I'm going to highlight my table. I'm going to go to borders, and I'm going to go to no borders. Okay, and so because we have kind of the tick marked boxes here, we're just viewing the lines. They're not actually going to show up when you print and stuff like that. Okay, and so from this point, we can then go in and start creating a table. And we're going to create this table based on the data that is in our ANOVA analysis. So I always start with the headings. So we'll just start with item first. And then our treatments are bone in, off all, boneless, off all. And then I'm going to add a column for standard error of the mean, abbreviated as SEM. And I'm also going to, let me do layout, add one more column at the end, and this is going to be for the p-values. So we title the p-values P greater than F. Okay, and so that just goes back to our ANOVA analysis where our F value is our cutoff value that determines significance. The p-value, if it is less than the f-value, we have significance, okay? All right, so then now that I've got my headings in place, I'm going to do a couple of things here. I'm going to go ahead and put a border underneath it. Okay, so that border is going to separate the headings from the data. And then we can go in here and put some items in. And so let's say that I think there's a lot of nutrient data. So we're doing 5 different pieces of nutrient data. So we'll make this table just about the nutrients. Okay, so we'll do, I gotta go back and look really quickly, sorry. There we go. So we got total N. That's going to be in a percentage. Total P. Potassium is in a percentage. Organic matter is in a percentage. And then we'll add one more row below this, and we'll do moisture, which is also in percentage. Okay, so now that I've ran that, what my next step is to go back and look at my individual ANOVA analyses from Excel, and then put in here the means for the individual treatment groups. Okay, so let's say that total nitrogen was like 0.29. Okay, so 29%. And actually that's really, really high. So let's go 0.02. Okay, so 2%. And boneless was 0.03, 3%. And I'll show you how to kind of do standard error of the mean here in just a second. But let's say standard error of the mean ended up being 0.001. And our p-value was not significant. It was 0.06. Okay, so that's how we would actually go in and build our graph. But what we want to do is we want to make it look pretty when we get all of the data in there. So the next thing we're going to do is we're going to put a border at the end of this table. Okay, so we've got the borders actually signify the beginning and the ending of the data. The column over here to the left, this can be left justified just like it is. Okay, but the data that shows up and the headings for the rest of the table, these all need to be centered. So we can go in and just center them. Okay, if I have another set of data that for phosphorus that has more variables than the total nitrogen does, and it makes our, let's just say we've got 003, or sorry, I didn't do that right, 003, there we go, and 0.005. Okay, so what we want to do when we organize the data and make it look pretty is we want to make sure the decimal points are lined up. And so in order to do that, what you may need to do is go back and left justify them. Okay, actually, no, hang on. We can keep them centered. And what we can do is just space them over so that our decimal points are going to be in a line. Okay, and these are things that just make it a lot neater, a lot more concise, and ends up taking up less space in the long run, which we as scientists are really interested in, because keep in mind, it costs us $2,000 to publish one page of a peer-reviewed journal article. So we're going to put as much information into the least amount of space as possible. And that's what's really nice about tables. Okay. The other thing that I like to do as far as creating tables is just to keep everything together, I will actually go back in and add a row up here at the top. And I will take the border out and do no border there. But then I will also merge the cells together. And I make this, once I left justify it, the table title. So if this is table 1, period, we'll say that this is the mean, and then we can insert. So we go to insert symbol plus or minus mean plus the standard error of the mean, or SEM, which is this guy over here. Okay, we'll say, then we'll list out all of these individual components here. So we'll say of total nitrogen, total phosphorus, potassium, organic matter, and moisture percentages of bone in and boneless offal compost. Okay. There we go. So that kind of gives you an idea. And then the other thing that we need to make sure that we add in here is the number of samples we have for each treatment group. And so we have 3 samples for each treatment group. So we'll just do N equals 3 there. And we'll do N equals 3 here. And then we've got a pretty close table title. So we've got the dependent variables, which are all of these right here. We're going to make it look pretty though and spell these out. Didn't spell that right. Potassium, organic matter, and moisture percentages of bone in and boneless offal compost. Okay, and then once we fill in our data, we actually have a fairly decent looking table. So that's just a really quick overview of how to create a table in Word. All right, so let me go back to the PowerPoint slide. I just want to make sure that I've got some notes as far as how to make a table and some things to watch out for. That is not what I wanted. There we go. So again, this is very detail-oriented work, okay? And so when it comes to important features for a table, this is an example table. It has nothing to do with our research project, okay? But it is a good one that got the full amount of points from a previous class. Okay, so here you can see that the table title is always above the table. That's not going to be the same for graphs and figures. Okay, so table titles are always above the table, and figures titles are always below the figure. And so you'll see the difference here in just a second. So keep in mind that figures and tables should quote unquote stand alone, meaning that if your reader was only presented the table and the title, they could figure out what it meant. Okay, so they would know what the treatments were, they would know what the results were, they would know which ones were significant. So that's what it means by standalone. Okay, so some things to keep in mind. The T in table up here is always capitalized. So once we create a table or a figure and we refer to that in our results section, it becomes a proper noun. Okay, and then just keep in mind that the title needs to fully explain what is in the table. Sorry, I should have taken that out. What is in the table. So it needs to list the independent variable, which is going to be boneless and bone-in treatments for our study. In this example here, it was actually location. So we had Shasta and Butte County locations. It needs to include the dependent variables. So in our compost study, that's going to be like temperature or moisture or nutrients. Okay. In this example here, we actually have the dependent variables are manganese, selenium, and copper in cow blood samples. Okay, and then we need the number of experimental units. So in our compost study, again, that's going to be compost mound. Okay, and we put in n equals 3 after the bone in, and then again after the boneless notation in the table title. Okay, and so our and then the last thing is just the location or the experimental unit. So in this example here, this was grazing location. Okay, and then in our compost study, that is actually going to be the compost mounds. So those are just a couple of things to keep in mind about the table title. Let's look really quickly and talk about p-values in a table. So for your guys' purpose and for the purpose of most of what you're going to see in undergraduate research, we can pretty much always just include a column for the p-values. And so in a table, we call that p greater than f. Okay, it's going to be different in a table or in a graph. And so P's should always be in italics. Okay, so this P right here should have been italicized and it wasn't. I forgot to change it. Okay, and then just a personal preference. So with p-values that are not significant, rather than writing out their actual p-value, you can actually end up grouping some of those together in your text. Or in a table like this, you can leave it as p is greater than 0.05. So right here. However, for p-values that are significant, it's important to show your reader how significant they are. So those should actually be actual p-values. So for example, if we had in this example, manganese was different in the Shasta County location compared to the South Butte location at a p-value of 0.01. We actually wrote it out here. So, all right, table lines, we already talked about this. So horizontal lines are the only lines that show up in tables. Okay, so again, we're going to separate the headings from the data that's being presented, and we want to make sure we have an ending line at the end of the data to signify the end of the table. All right, so really quickly before we jump into figures, does anybody have any questions about tables?
Could we go over at the beginning exactly each of the tables that we're making?
So Ryan, you guys actually get to make that choice for yourself. Okay, so you can, depending on how the data is, or the result, what the results of the data are. So like after your ANOVA analysis and that type of thing, you can make a decision on whether to present it in a graph or in a table or in paragraph form. All you need is at least one graph or at least one table to check that box on the rubric. So is that more clear for you?
Yeah, because at the beginning you had a whole list of nutrient data, temp, moisture, and each were saying ANOVA next to them. And I wasn't sure if we're supposed to make it for every single one of those or.
Okay, so let's just go back and make sure we're all on the same page. I want to be as clear as possible. Okay, so these slides up here, these are just a checklist for you guys to make sure that you run the analysis for the different traits. Okay, so once you actually get the data here, you can figure out the best way to present that. So it might be in a table, and it could be in a table where you group all of the temperature information together, or you could put all of this information for day 1, 18, and 38 on a graph. Or you might make a big table or a big graph with multiple bars and group temperature and moisture data together. Okay, so that's what we're actually, you can't do that. So sorry, ignore that, because the values and the units that these are measured in need to be the same if you're going to report them in a figure together. They don't necessarily have to be the same if you're going to report them in a table. So again, these were just a checklist for the different analyses that need to be done. And then, but you get to choose how you want to report those analyses. Okay, great. Thank you for speaking up. Any other questions about a table before we shift gears and talk about figures or graphs? Okay, cool. So show of thumbs. How many of you guys have a love-hate relationship with graphs in Excel? Couple. Okay, cool. So this is usually the part that takes a little bit of time, and it's the largest amount of the questions that I get for this project is always about how to create graphs. And so I'm going to really quickly kind of take you through how to do that. So you'll have this recording to come back to, and then you can always drop into the writing workshops as well. Okay, so with a graph, you can do this in a couple of different programs. So you can do it in Excel, that's totally fine. And you just copy and paste it out of Excel into your Word document, or you can create it in PowerPoint. Okay, so most of the functions are the same. I think there's a little bit more flexibility, and I have a little bit more control over how it looks in PowerPoint, but that's just my personal preference. So today I'm just going to walk you guys through how to make a quick graph in PowerPoint. All right, so we'll just do it on this slide here. So we're going to go to the insert tab. We're going to go to the chart, and this window is going to pop up, and I really like column charts. Okay, if for the regression analysis, I would probably use a line graph. Okay, but let's just start with a column here. So if we choose a clustered column, it's going to take a minute to populate. Once that pops up, it's also going to pop up with an Excel spreadsheet, essentially. And this is where you can enter the data. You can also rename the series and the categories. So let's synthesize some data for like the bone-in, boneless study. Let's look at temperature and moisture, okay? So let's look at day 1 temperature and moisture. So let's do temperature for that series, and then moisture, and we'll do day 1. We'll do temperature day 1 too. Okay, and then I'm gonna go ahead and get rid of series 3 here. So I'm just gonna delete that. Okay, so now the purple bars are going to be temperature data, and the moisture bars are going to be in orange. And so our first category here is where we can actually put in our treatment groups. Okay, so let's do the first one is bone in, and the second one is boneless. Okay, cool. And I'm just going to go ahead and delete these last two rows here. So now we've got the bone-in data, which is going to be presented first, and then the boneless data, which will be presented second. And we can go in and actually plug in the means from the ANOVA analysis here. So for example, let's just say that temperature on, oh, you know what? This isn't going to work very well. Let's just do temperature. I'm going to delete moisture right now. And the reason I'm deleting moisture is because the units that they are measured in are not the same. All right, so with temperature, let's say that bone-in offal was, I think this was like 121 on average. And then boneless was 131 on average. Okay, so we've got a fairly big difference between bone-in and bone-off offal. The other thing that I will add here is the standard error of the mean. So the SEM. And this is actually calculated, but I don't want to include it as a graph. So we'll run that back over there. So in the ANOVA analysis that you run in Excel, there is going to be the variance column in the output. And what I usually do, it's not the best way to handle this statistically, but it's the way that we're going to do it because it's easy. We're going to take the average of those two variance values, and that is going to be the standard error of the mean. We call it a pooled standard error. And so what we're going to do is we're going to put it in here, and we're just going to say that it's like 1.0. Okay, so and the reason that we're going to do that is because we need to add standard error bars to these columns here. So we can go to the plus sign over here on the right hand side, and we can check the box that says error bars, and we'll then click on the arrow and go down to more options, and that'll bring up this window over here on the right hand side. And we always want to make sure that we are not using the default standard errors that PowerPoint gives us. So we're going to go, instead of just moving forward with what is reported for standard error by PowerPoint, we're going to actually choose a custom value. So we'll highlight custom, and we'll go to specify value. And then we have a positive error value and a negative error value. And what you're going to do is you're going to actually use the same number here. So we're going to click into the cell, and we're going to choose standard error of the mean of 1 for the positive. We're going to use the same number, standard error of the mean of 1 for the negatives. And then we're going to hit OK. And that changes these standard error bars to actual values that are associated with the analysis. All right, so that gives us basically what we need. We need to go back in here and actually like include some, gosh, I'm probably way over time. Include another axis title. Okay, so this guy over here is going to be temperature. Come on, buddy, come on. And this is going to be in degrees Fahrenheit. Okay, and then this axis title down here is going to be compost. We'll just say compost type. Okay. And then I always like to pull off these titles that are up here, because what we're going to do is when we get copy and paste this into Word, we are actually going to put in a text box below this and write out our figure title. All right, so that is what is a really quick way to actually create a graph in PowerPoint. A lot of the same principles will apply in Excel as well. All right, so just some really quick comments about things to make sure that you are watching for with a figure. First and foremost, so this is going to be the example that we're going to use in the next few slides. This is from last fall, where we were looking at 3 different treatments: a Shasta treatment, a North Butte treatment, and a South Butte treatment. And these were grazing locations. And we were actually measuring metabolites in the blood, or minerals in the blood. So copper, selenium, and manganese. And so this is an example of copper. Right, so first things first is you will notice that the figure title is down here below the figure. So anytime we have a graph or a picture or an image, anything that we're calling figure, we're going to refer to it as a figure and give it a number. Okay, so if you have multiple graphs, and let's just say that you're going to present temperature and moisture in a graph, you're going to have figure 1 and figure 2 both. Okay, and so our figure title is going to be complete. So it's going to help our actual graph stand alone. Okay, so this is going to be the mean plus or minus the standard error. Standard error is shown by the tick marks here on top of the bars of mature beef cows grazing annual rangeland locations in Shasta County, where there were 10 samples taken. North Butte County, also 10 samples taken. South Butte County, 10 samples taken in Northern California. All right, so just a couple of notes about the figure title is that figures need to stand alone. And then the F in figure down here in the figure title needs to be capitalized for the same reason that we did that for tables. Okay, so once we've created this image, we've made it a proper noun. And so now we're going to refer to it with a capital. All right, and then the number of the figure and table is going to be sequential. So if you talk about temperature first in the paragraph of results, then the figure 1 needs to be about temperature. All right, and then again, the title needs to fully explain what is in the graph. So it needs to include the independent and dependent variables, as well as the number of experimental units. We need to make sure that we fully and completely label our axes. Okay, so our x-axis is down here. That more often than not is the treatment groups. Okay, and so but we don't want to call it treatment groups. We want to be more specific than that. So in our compost example, that would be compost type. So either we had boneless or bone-in compost. Okay, in this example here, our treatment group was grazing location. So again, we get more specific than just using treatment. And then over here on the y-axis is going to be the unit of measurement, or the dependent variable. And so in this example, it's copper, and it was measured in parts per million. Okay, so our compost examples are going to be, if you choose to do temperature or moisture or total nitrogen or potassium or phosphorus, that's what is going to show up over here. Now, just a quick note while we're talking about units on the y-axis, if you guys want to present all of your data in a graph, what you can do is actually just make sure that the units are going to be the same. So for example, in the nutrient analysis, where we've got total nitrogen, phosphorus, and potassium, those are all measured in percentages that are relatively close to one another. You could probably take all 3 of those for both of the treatment and put it into one graph. So you really start to condense down how much space you're using up to report your data. All right, and then the p-value, actually we'll get to that next here. Okay, so the p-value needs to appear on the graph somewhere. So here's a great example of, you can put a p-value just using a text box up in one of the corners of the graph, or you can actually mention it down here in the figure title if you want it. It only needs to show up one place. And then the superscripts, sorry, let me do superscripts really quickly. So these superscripts actually relate to significance. And I don't know if it's good news or it's bad news, but in our study, we only have 2 treatment groups, bone-in and boneless. And so if we have a significant p-value, that means that we have significance between one of the 2 treatment groups. The reason that we use superscripts in this example is because we have more than 2 treatments. So the p-value that's reported up here in the text box tells us we have significance, but if we don't label which bars are actually or which treatments are different from one another, we can't tell if it's the Shasta that is different from North Butte or Shasta that's different than South Butte, etc. And so we'll use superscripts above the standard error bars to signify significance. So if, and this is just for your information, you guys aren't going to use these in your study, but you need to know how they come about. So these superscripts that are the same, or common superscripts as we call them, means that they did not differ. Okay, so in this example, the Shasta copper levels were not statistically different from the South Butte copper levels. But the Shasta copper levels were significantly different from the North Butte levels, and North Butte was significantly different from South Butte. So the reason that we know that is because we have different superscripts between those North Butte bars as well as Shasta and South Butte respectively. So again, I just want you guys to know about superscripts. There really isn't a reason for you to use them in our study because we only had 2 treatment groups. Okay, let me go back and talk about error bars really quickly. So I showed you how to add those on to PowerPoint. There's lots of good YouTube videos out there if you don't remember or you need a further explanation. But the standard error bars are going to be these little tick marks that show up on the top of the mean bars. And so what you can do is you can go to the plus function in PowerPoint, add standard error bars, and then open the standard error bar window, click custom value, and then you can use the value that is calculated from the variance of the ANOVA analysis that you did in Excel. And you can use that for the upper limit or the positive limit, as well as the lower limit or the negative value. And so just keep in mind that we want to make sure that we have standard error bars on all of our figures. And we also want to make sure we have, if we're using a table, we have standard error values associated with those data as well, because standard error is really, really important because it signifies how much variance there was among our treatment groups. Okay, so as far as discussion, I just kind of put this together as a rough suggestion. Okay, so again, you guys don't have to use this. You're not boxed into this. It's just a suggestion. Okay, but the discussion part of the scientific paper, aim for 5 to 6 paragraphs. Okay, so kind of similar to the introduction. The first paragraph can be really short, and I'm fine if it's only 1 sentence. So what we want to do is reintroduce our reader to our objectives. And the reason that we do this is because if we think about where the discussion section actually shows up after results, our reader just spent a really long time reading through all of our materials and methods and our results. And they may have forgotten about what the objective of the study was. So because the discussion section is where we bring everything together, our results in literature, weird stuff, not weird stuff, etc. It's really good to start with that first paragraph by reintroducing the reader to the objectives. The second paragraph, I think, fits really nicely with our compost study. It could actually talk about the results of objective number 1, where we looked at temperature, pile height, and moisture. Okay, paragraph number 3 could talk about the nutrient analyses. So we looked at 5 traits in the nutrient analysis. And so all of those results could be discussed in paragraph 3. Paragraph 4 could talk about the regression analysis. Okay, and so that regression analysis is where we assess the strength of the relationship between pile height and temperature. And you guys did that last week. Okay, so you already have some things that you have thought about relative to the regression analysis that could be changed for the future. And that leads us into paragraph 5. So typically you can use one paragraph to talk about shortcomings in your research or things that went wrong or should have been done differently, as well as the next steps for the research. Okay, so I want you to put some thought into things that could be changed. For example, we discovered last week that when we were trying to regress pile height on temperature, those probably weren't the 2 best traits to try to establish a relationship between, right? So what would you suggest in future research to try to establish a relationship between? So I had you guys think about that in one of the questions last week. And so I encourage you to maybe incorporate that into the discussion as well. So please keep in mind that the discussion section of your paper is where you report your findings. So what were the results of your study? And then you go out and find what other people have found about those traits or those relationships, okay? So you're comparing the results of your study to what is already out there in literature. So this tends to be a big critical thinking section, okay? So this is where you may need to spend some time kind of pondering like, okay, if we had a difference between these 2 traits in the bone and the boneless, what could be causing that? And so that's where you allude to it here in the discussion. And so you need to make sure you're using appropriate references in the discussion. And you can start with those references that you wrote the introduction with. Okay, but don't limit yourself. Go out and find other information that is out there in literature, okay? All right, so again, the last thing I just want to mention is that we analyzed a ton of data. There's a lot to talk about. So if you are finding that one paragraph is not enough room to talk about everything that has to do with temperature or everything that has to do with nutrients, that's okay. You are more than welcome to split it up into multiple paragraphs. Okay, and with that, I ran over a little bit. Hopefully that gives you guys a better idea of what we need to work towards this week to wrap up part 3. So we're already over time. I apologize for that. This recording will be up at the end of the session. And then if you guys have time and want to hang out for the next discussion sections, you're more than welcome to do that. So in the meantime, I am happy to take any questions that you have before the next group comes in.
For the standard error of mean, did you say that was the variance like number on the tables?
Yes, so that first table, the summary statistics in the ANOVA analysis that
Yes.
has like the column for average,
Mm-hmm.
and then the next column over should say like variance, I think.
Yes.
The variance is the standard error.
Okay. And then for the ones that have like are in decimals, how far out did you want us to go with that? Like 2 decimal points, 3?
On the percentages?
Yes.
I would go, I think I would go out 4.
Okay.
Great questions.
And then is there a way to basically like help us decide whether we should use a table or a figure in our paper, or is it just kind of like whatever we would like and feel would best describe it best?
Probably the latter one, but if you want to run it by me, I'm happy to give you my opinion.
Okay, thank you.
Yeah, you bet.
I think I figured out where I was confused earlier.
Okay.
Just because like when you talked about the objectives of our studies, that's what we're building graphs or tables around, correct? Like we're addressing each one of those objectives with the results.
Yes.
And
Yep.
so we're running an ANOVA for all those components and compiling them into tables or figures that we would then interpret.
Yes.
And, okay. I was just getting really confused about the ANOVA tables that we're running. And okay, I see how the data is going to be analyzed and then organized and then interpreted.
Yeah, it's definitely a multi-step process.
Sorry, I was just like, do we have to run an ANOVA for every single one of these traits? And then we're going to have like a billion graphs and tables just to convey all that information.
Yeah.
But then I realized we're comparing the ANOVAs in the table. Is that more correct?
Not necessarily comparing, but reporting.
Reporting,
So
yeah.
you are running all of those ANOVAs. Okay,
Yeah.
but the way that you report it is where you can get creative and condense it down.
Gotcha. So it's like we have the temperature and moisture for bone in and bone out, running a ANOVA analysis on those, and then we're putting those in a graph or
Yep.
table
Yep.
and then interpreting. Okay, thank you. I was
Yeah.
really, it was like with the double negative of rejecting the null, I just needed
Yeah.
to really think it out.
Yep. Nope. I understand. So, and bring me your questions as you have them. Okay.
Okay, thank you.
Yeah, you bet.
I have a question real fast. So for results,
Yeah.
like, so for the discussion, it's talking about the results, right? But
Yep.
then in the results, we're also supposed to talk about the results. Like, what do we, like the,
So I totally understand why you're confused. So in the results, you were reporting what you found. Okay, so in results, you're not going to use ANOVA tables. You're not going to put those in your paper.
right.
So, but it's important for you to report like, okay, so a good example sentence would be something like, no significant difference was detected for temperature on day 18 between bone-in and boneless compost types. And then at the end of that sentence, you put in parentheses, P greater than 0.05, period. So those short, it can just be a series of short sentences like that. And all we want to know is if there was a significant difference or if there was not one. Because you're going to put and I should have said this, because you were going to put the data in either a table or a graph, like the means in a table or a graph, you don't need to report them in the paragraph. You just got to say if they're significant or not.
Okay. So the results is pretty much just the tables and saying like a sentence of if it's significant or not, and then the discussion is where we really get into it.
Yeah, exactly.
Okay.
So Nicole, don't be afraid. Go look at the example papers from last semester.
All right. And then when I was trying to do my analysis for the nutrient one for the ANOVA, it was not letting me because it said something about like the numerical. I didn't have like a numerical data set or something.
Oh, I can fix that. So what it is seeing is text. So you just need to highlight all those cells and then right click, go to format and format them as a number.
Format them as a number. Okay.
Yep. and try it that way. Hopefully it works.
Okay, sounds good. Thank you.
Yeah, you bet. Okay, guys, I've got to let the next group in. You're more than welcome to hang out. But it's going to be exactly what we talked about. Hopefully ish, maybe with some different questions. Hi guys, good afternoon. How are you doing?
Pretty good.
Awesome. Okay, we're gonna give it just a minute. There we go. Okay, I need to go check on a puppy really quickly. She's sleeping.
What kind of puppy?
A Borgie.
Oh, those are cute.
They are cute. They're worthless, but they're cute. So my aunt has 2 corgi females, and then my cousin has a corgi male, and somebody wasn't paying attention in June. And so both of the females got bred. So they had 14 puppies in August, and it was like a madhouse. And this was the only puppy that wasn't spoken for. And they were going to keep her, but I kind of felt bad about it because they already have several dogs that run their lives. And she would just be another one. So, and my poor dogs are getting old. So I felt justified. But yeah, she's cute. If she wakes up, I'll let you guys look at her. She's cute. But I'm totally biased. So, but she's also a little piranha. Oh my gosh. Okay. Enough about puppies. Sorry. Welcome to week 13. So I just did a really extensive rundown in the first section, which was recorded. In fact, I'm going to pause recording.